Good afternoon, everyone. Today I'm going to deliver my second micro teaching class. Before we go, just for quick questions, what do you think this world is composed of? Well, I mean, what is matter composed of? Some tiny particles, right? What are these tiny particles? Do you know that?
Atom.
Probably. You know?
Atom.
Neutrino.
Right. This is exactly my topic today, the atom. We all know that atom is a basic unit of matter. All matter are composed of atoms, right? But do you think an atom is dividable? I mean, can we divide the atom into even smaller particles? Yeah. Yes, right? There are parts inside there. Let me show you what they are. An atom consists of a dense nucleus surrounded by electrons. If you look at this picture here, the small spheres out there are electrons. And the center core, the large core there, is a nucleus. Okay? Now, for detailed definition, electron is a light particle with a negative elementary electric charge. And the nucleus is a dense core, which I'm going to explain a little more. You see there, the electron is actually a particle, but the nucleus is not actually a particle. The nucleus actually contains two kinds of particles, the proton and the neutron. The proton is a massive nuclear particle with positive elementary electric charge. And the neutron, as you know from the name, is of course electrically neutral. But it has also the similar mass to the proton, which means it's massive. Okay, we have introduced three kinds of particles which inside an atom: the proton, the electron, and the neutron. Okay, but they have charges and masses, but they're different, right? Let me go over the things for you. The proton has exactly the same electric charge as the electron, but they have different signs. If you remember, the proton has positive electric charge, the electron have negative. Okay, but the amount of charge they contain are exactly the same. However, the proton is 1,800 times more massive than the electron. And the neutron, if you look at the picture here, this huge thing is a proton, and the small thing is the electron. If you think the electron as a mouse, the proton looks just like an elephant. Okay, and the neutron, since it has almost the same mass as proton, is just another elephant. Okay, but remember, this elephant and mouse have the same amount of electric charge. Okay, now that I have given several examples of three subatomic particles, electron, proton, and neutron, let us have a very brief summary about the characteristics. They're characterized by their charge and mass, right? I can make a table out here. Could you tell me what electric charge they have? For electron, what electric charge does it have?
Negative.
Yeah, it has negative. And for the proton, what charges does it have?
Positive.
And what's the relationship between these things?
Same amount?
Yeah, same amount of the sign. And the neutron is, of course, neutral. Okay. And think about the mass. What's the mass for electron? Does it have a high mass or low mass? Of course. And for proton and neutron, they are very massive, right? I'll just use H4 high there. And in which location are they found? In which location of the atom are they found? Are they all together, or are they each have their own space?
Are in neutron.
Yeah, these two both live in the nucleus, while the electron orbits outside. Okay? This is a brief interview, the table of three particles, so you can see it's pretty clear the difference, right? And notice that they are primarily prioritized by the charge and mass. I'm going to explain why why I'm paying so much attention to the charge here. Now, if you see the picture, I can actually give you a detailed picture of an atom here. Notice that I've already put the charge numbers and the details of the nucleus, okay? All right? So basically, this is a picture of the atom. And now, since I have known the structure of this atom, we can talk about okay, before before we talk about the next one, can we just do some very brief true and false questions? First one, just to make sure, is this statement true or false? Electron has a negative charge. Is it true or false? Of course, right? And second, proton and neutron has almost the same electric charge. It's false, right? It's a little bit tricky because proton and neutron has almost exactly the same mass. And neutron, because neutron is, of course, has no electric charge. All right? And the proton and the electron has exactly the same electric charge. Okay. The third one, an atom consists of four kinds of particles: the electron, the proton, the neutron, and the nucleus. Is this right? This is another tricky question. The answer is false, because nucleus is not a particle. It's a part that is composed of proton and neutron. All the three particles we have is electron, proton, and neutron. We can say it either two ways. We can say it this way. The atom consists of two parts, the electrons and the nucleus. Or we can say an atom consists of three kinds of particles: the electron, proton, and neutron. Okay? But you cannot see it this way. Okay, now that we talked about the structure of the atom, we can talk about the properties of the atom. Notice that I pay special attention and emphasis on the charge and mass here. Do you guys have any guess why I would pay attention to these properties, not the other properties like size or color or whatever? Okay, I'll explain to you. Because mass will determine the gravity, if you know. Gravity acts on mass, right? And charge will determine the electromagnetic force, because the electromagnetic force acts on charge. And here, as things turns out, the electromagnetic force plays a major part. The magnitude of electromagnetic force is way too large compared to the gravity. So that's why these two properties are important, and that's why we pay primary attention to charge instead of mass. Okay? Well, and the other thing about the atom is that the atom has to be electrically neutral, otherwise it is not stable, right? Because you know that the same kind of charge tends to repel each other, and opposite charges attract each other. If the atom has a net charge, it will not be stable. Okay? So to hold it stable, as you can see from the electric charge here, inside an atom, the number of electrons and number of protons must be exactly the same. Otherwise, this atom will not be stable. Okay? So this number, the number of protons or the number of electrons, is kind of important. We call it the atomic number. And actually, we can divide the atoms, we can classify the atoms according to this number. We classify the atoms by their number, because the atom, if they have the same number of proton or electron, they have the similar properties, because electromagnetic force sees them as this force, no matter how many neutrons they have. All right? So then we have a name element, which refers to the type of atom with the same atomic number, and as you see, they have similar properties. Okay? But for an element, of course, for an element, the atom can have different numbers of neutrons. In that case, we call them different isotopes of the element. Okay? To get it more familiar, let's look at this example. This is the carbon atom, the carbon nucleus, actually. You can see from here that the carbon 12 has 6 protons, 6 neutrons. And all the 3 isotopes are isotopes of carbon because they are the same element, because they have 6 protons. So they have the same element, and they have the same properties. However, the number of neutrons are different, and that makes them isotopes. Just one question: how many electrons do each of them have? How many electrons? I'm not putting here. How many electrons do each of these atoms have?
6.
Right, exactly, because the number of electrons has to equal the number of protons here. Okay, so I think 16 is here. That you probably understood the importance of element and isotopes. Okay, same elements, no matter what isotope is, will have the same kind of property because they have the same number of electrons and protons. Okay, let's go sum up our presentation here. First, we define the atom. Can any of you give give a definition or description of an atom, you can say it whether what are atoms, or you can say what is an atom composed of. You can define either way. Can you define it for me?
Nucleus plus electron.
Yeah, that's the components. And remember, the atom is the basic unit of matter. Okay, all matter consists of atoms. And we talked in details about three particles inside: the electron, the proton, and the neutron, which are characterized by charge and mass. It's very clear out here on the table, so I'm not going to repeat it. And we noticed that one number, the atomic number, is very important. What is atomic number? Yeah, the number of the proton or the number of the electron, because they are the same. And why is it important?
It determines the property of the atom.
Yeah, exactly. Then we talked about the elements and isotopes. The people of the atoms with the same atomic number are called same elements, and they have exactly almost the same properties because they have the same number of distribution of charge. Okay, and the isotopes are just same atom with different number of neutrons. Okay, so you have pretty much know everything here. Do you have any questions?
Oh,
Sure.
yeah. Could you show me the example of carbon
Sure.
isotope? Yeah. Why are there many carbon 12 but so few carbon 14 and 13? What is does?
Oh, you mean the
Yeah.
the percentile?
Yeah. Do
Oh.
they have any difference in?
Yeah, they have differences because, well, it turns out that heavier nucleus are less stable.
Oh.
Well, if a new carbon is 14, you have 8 neutrons. There will be some process inside nucleus called decay, where a neutron turns into other particles like protons and electrons, and this will go into another particle. And that carbon 12 is the most stable. That's why they can find a lot of carbon 12, but less 13 and R3. Okay. Any other questions? Okay. Thank you very much, and see you next time.